We're going to learn about right triangles in specific today. So we're going to talk about altitude and hypotenuse of a right triangle and how that will divide it into two triangles that are similar to the original. And then we're going to learn what a geometric mean is, and we're going to compute lengths inside of related segments for right triangles using proportions or geometric means. So first of all, let's review what is an altitude. An altitude is drawn from the right angle, that means the 90-degree angle, and it's going to go to the other side, to the hypotenuse, right? So the other side of the right angle is the hypotenuse. So it's drawn from the right angle to the hypotenuse. And that's going to separate that triangle into two similar triangles. Not only are these two triangles similar to each other, but they're also similar to the original triangle that we had. So here's an example. As you can see, here's our altitude drawn from the right angle going to the hypotenuse. So now we can see that triangle BDC, this triangle here, is similar to ABC, the original. And triangle ABD, this smaller triangle, is similar to BDC, the other triangle. Alright, let's look at this proportion. A over x equals x over b. Notice that the denominator of this first ratio is the same as the numerator of the other ratio. When this happens, it's called a geometric mean. X is called your geometric mean. So for example, in this proportion, notice that the 8 is here. Notice that the 8 is here in this denominator, but in this numerator. So we can say that 8 is the geometric mean between 16 and 4. Let's try an example. Let's find the geometric mean between 3 and 27. So the first thing we can do is set up a proportion. We know that 3 will be the numerator and x will be in the denominator for the first ratio. And in the second ratio, x will be in the numerator and 27 will be in the denominator. Now we can use cross multiplication, which says that x squared is equal to 3 times 27. 3 times 27 is 81. Now to solve for x, we square root both sides, and the square root of 81 is 9. So our geometric mean between 3 and 27 is 9. Let's do another one, 6 and 9. Go ahead and see if you can figure this one out yourself and pause the video. Alright, you should have set your proportion up like this, which means that x squared is equal to 54. And then when we square root the 54, we cannot leave it as the square root of 54 because that is not simplified. First, we have to break 54 down. 54 can be broken down to 9 times 6. When you break down the inside of the radical, you want to break it down so that way you can find something that you can take the square root of. So remember, we can't take the square root of 54. However, if I break 54 down into 9 times 6, I can take the square root of 9. The square root of 9 is 3, so my answer is 3 square roots of 6. Now the 6 can only be broken down into 2 and 3. Neither of those I can take the square root of, so I can stop. I'm done. The square root of 6 cannot be simplified any further, so my final answer is 3 square roots of 6. Let's try 5 and 25. So 5 times 25 is 125. But the square root of 125, I can't take the square root of it. However, it can be simplified. It can break down to 25 times 5. And I can take the square root of 25. The square root of 25 is 5. So I've got 5 square roots of 5. If I put that in my calculator, I would get approximately 11.2. Let's look at another theorem. In a right triangle, the altitude to the hypotenuse cuts the hypotenuse into two segments, okay? So that gives us two segments that create two separate triangles. The length of the altitude is the geometric mean, so that's important. The length of the altitude, right? That thing that's going from the right angle to the hypotenuse is our x, or our geometric mean, between the lengths of the two segments of the hypotenuse. So here's our x, right? Here's our numerator for the first one and our denominator for the second one. So we get a over x is equal to x over b, or the segment AB over segment DB is equal to DB over BC. So notice I can write it either way. I can write it with the names given the segments, or I can actually give it by the segments themselves. Let's look at another theorem. The altitude of the hypotenuse divides the hypotenuse into two segments, such that the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. That's really useful. Look at that. So for this one, AB over AD, so this hypotenuse. So this hypotenuse is our geometric mean. So this is going to repeat again, AD over AC. So notice it was the short segment over our geometric mean equals our geometric mean over the entire segment. We can also do it this way. BC, so our short segment, over DC, the hypotenuse, is equal to DC, the hypotenuse, over AC, which is the entire thing. So given the measurements in triangle HIJ, let's find X, Y, and Z. So, well, to find X, we can use the two segments that the altitude splits into. So 4 over X is equal to X over 16. So X squared is equal to 64. The square root of 64 is 8. So now we know that X is 8. Let's try to find Y. Now Y is this side here. So we're going to do little over Y equals Y over big, right? So Y over 4, the smaller segment, is equal to Y over the entire segment, and 4 plus 16 is 20, so we get 20. So Y squared is equal to 80, and the square root of 80, well, the square root of 80 we cannot take, so we have to simplify it. The square root of 80 breaks into 4 times 20, and 20 breaks into 4 times 5. So we get the square root of 4 times 4 times 5. Well, the square root of 4 is 2, and the square root of 4 again is 2, and then 5 we can't take the square root of. So we get 2 times the square root of 5, which is 4 square roots of 5. Let's find our Z now. So Z is this entire segment here, which is our geometric mean. So we're going to do short side first. 16 over Z equals Z over the entire thing, which is 20. So 16 times 20 is 320. 320 can be broken down to 64 times 5 because we can take the square root of 64. The square root of 64 is 8, so we get 8 square roots of 5. All right, that is the last example. It's your turn. Go ahead and try 2 through 6 evens for your homework.